Today's topic is approximation. So we're doing approximation almost every day actually, because we rarely use the actual value of anything. For example, we will say, oh, it's 11 over 7, or do we say, oh, it's like approximately 1.57, or even 1.6. The fraction is the actual value, is the very accurate value. The recurring decimal is also very accurate. Yes, it's like no information is lost. However, from here to here, there's less information. So why do we do approximation? In practice, it will be more convenient to use a smaller number, or like a number with less digits or less figures. They will be less accurate. However, it will be more convenient to use. So we can either correct this to 3 significant figures or correct it to 1 decimal place. So, and 3 significant figures means we are only keeping the 3 most significant figures. So in here, the first 3 will be the most significant because it represents the most of the values of this number. And these are the 3 significant figures. This 1.444444 reoccurring, and then we're only keeping 2 of the 4s. Including the 1, there will be 3 significant figures. For the second way, this is correct to 1 decimal place. So 1.6 here, 1.4 here. This is 1 decimal places, 1 digit at the right hand side of the decimal dot. And in this sense, they are much easier to compare, right? So 1.6, 1.4, oh no, this one is larger, this one is smaller. And although, yeah, technically we can still use the recurring decimals, we can still compare, but then it'll be less convenient when you say, oh, this 1.571428 reoccurring is larger than 1.4 reoccurring. That's very troublesome, right? Yeah. So it's very convenient to approximate things. Although it will be less accurate, so it depends on how much accuracy do we need. Let's say we need the most accuracy, we need to be exact. Then either use the fraction or the recurring decimals. If we can afford to be more convenient, then let's say we do 4 significant figures. So then we are keeping the 4 figures at the left. And represent the most of these values. It's the most accurate we can if we can only write 4 digits or 4 figures. We'll say why we say figures instead of digits here in the next slide. So 1.6 here we do 2 significant figures, only keeping 2 figures from this number. And here I did not do 1.5 because 1.6 will be a more accurate approximation than 1.5 to this number, as there's a 7 here. So 6, 7, 8, 9 is more than 5. So 1.6 will 1.57, this number will be closer to 1.6 than closer to 1.5. So it would be wrong to say 1.5 here correct to 2 significant figures. 1.6 will be more accurate. It's not exact, but it is a better approximation because it's more accurate. Yeah. Then we have 6 significant figures. Oh, I can only keep 6 figures, and then the most accurate I can represent this number is Writing like this, 1.5 and 1.3. Again, doing 3 here will be more accurate than doing 2 here, because there's an 8 here. So, then, but if there's only one figure, then it's called to 1 single figures. Well, this is approximately 2. Very rough approximation. It depends on what we're doing. This may be enough accuracy. So why do you say figures but not digits? So let's say we are approximating a larger number. Let's say this one, this fraction, and then this is the recurring decimal. Both of these are exact. And then in here, we are correcting to 3 significant figures. Well, I can only keep 3 figures. So I may as well keep the leftmost 3 because they represent the most of this value, the value of the number. So 157. Oh, but I can't just leave 157. It will be a smaller number, another number. So I have to keep the 2 zeros as placeholder. They are still a digit, but they are not really a figure because they do not hold any actual value. However, they are a very important placeholder such that we know the scale of the number of the digits on the left. This is a 700, this is a 5,000, this is a 10,000. So we know this is a 15,000 and 700. Then without these two, then it's 157. Okay, so that's why we say figures, not digits. Because this has to be something like, if you say digits here, this has to be something like 5 significant digits, right? Then it will be a mess if we do this as well. Yeah. So then this is 2 significant figures. Oh, I can only keep 2. So again, 16 or 16 is better approximation than 15 here because of the 7 in the next digit. So that's why this is 16,000. Then go to 6 figures here. So so there's a 6 figures. So 3 here again better than 2. Then 22 to 1 7 figures. So 20. If you compare 20,000 and 10,000, 20,000 is a closer approximate. So that's why 20,000 is used in here if you call to 1 significant figures. Apart from using significant figures, we can also use decimal places. This is correct to 3 decimal places. So basically we are counting, next to the dots, how many digits do we place? Or how many decimal places do we use? So next to the decimal dot, 1, 2, 3 from here. This is the exact value, this is the approximate, and then this is 1.6. This is 1 decimal places. 1 point. I can only keep this one. And then 6 will be a better approximation than 5 because of the 7 here. And then compared to this 1.571, the next digit is 4. So 1 here is better than 2. Yeah. Okay. And this is correct to 5 decimal places. 1, 2, 3, 1, 2, 3, 4, 5. Again, 3 is better than 2 here because of the 8 here. Then you can also correct to the nearest integer. Okay, so then this is low decimal places. So instead of saying to correct to 0 or no decimal places, we will say correct to the nearest integer. It is the integer. And then 2 is closer to 1 to approximate this number. This is 1.571428, 571428. We are correct. Okay. So what if the next number is 5? Right? There's 2 8 here, then I know this is 3. Then 7 here, I know this is 6. What if it's 1.55? Then it is still 1.6. So we'll take the larger number if it is like in the middle cases. You see, right in the middle, then conventionally we use a larger number. Okay. So we are doing approximation because we want to kind of compare numbers conveniently. And in some cases, we are using approximation for other reasons. So this is a circle. This is the diameter of a circle. The C is the circumference. And then we find that, oh, actually, the circumference and the diameter are in the same ratio for every circle. So we say, oh, C is equal to KD. K is the proportional constant. And later we define the K as pi. Okay. And pi is calculated to be a number that cannot be exact. It's 3.14159. There's many more digits calculated. However, there's no exact value like a fraction like this. You can never represent pi in a fraction form like this. Yeah. So then we have to approximate it. So we say, oh, pi is 3.14 correct to 3 significant figures. And we don't know the exact value anyway, so may as well use a approximation that suit our need. How many digits do we need? How exact do we need to be for the calculation or for the measurement or for engineering purposes? Depends on our purposes. How many digits do we need? Yeah. So, and this is approximation. Yeah, see you in the tutorial of approximation.